Did anyone else just get taken out?
Yeah, I think we all did because it said the meeting.
It said this free meeting has ended.
Yeah.
Yeah. Okay.
So what we supposed to do?
I came back, so I'm pretty sure.
Okay.
So the class really just get something like that?
For real. So that class canceled. Go home. It's like, well.
I ain't gonna lie though. I had woke up thinking I was gonna start doing my WebAssign work. Boom. Class starts in 20 minutes. I said, wait a minute. Whoa.
Bro, I'm dealing with this. I'm working at Amazon. I have to do that job. Look, I'm at work right now.
Hey, I don't know what happened. Oh, I know what happened, guys. Remember, we only can do for 30 minutes?
Mm-hmm.
So they just cut me out. So
We can only do how long?
No, like Zoom, I didn't pay the premium version. I'm just using a free version.
Okay.
So they let me only talk for 30 minutes.
Dr. Harris, how you get your picture on here? I want mine.
I'm sorry?
How you get your picture on here? I want my picture on here.
You want my how to get a picture on there?
She want to be official.
Which picture?
You got a picture like where your name
Oh,
is?
that's when you go to Google and then you can set your icon, what kind of picture you want. This is picture that it's my Google picture.
Oh, okay.
Okay. So if you want your Gmail, you go to your Gmail and then set your icon. It will show in here.
Oh, okay.
Okay, now I need to broadcast, okay? All right, so you should get my screen in a minute. Okay, you got it right there. All right, so is everybody good now? Sorry about that. Having a free stuff, that's what you get, okay? You only
It's
get
okay. I'll do the same thing.
Yeah. I mean, like they say, if I want to get an education version, I have to pay $150 a month. And I was like, I don't have that kind of money, okay? So I don't know. I would talk to my chair about if somehow we can get some kind of account set up if we're going to do this for like the rest of the semester.
I really hope we go back to school.
Yeah, let's just go ahead and do like this for now, and then we'll figure out what to do. Because
Dr. Harris, I have a question.
Yeah. I'm sorry?
Okay. You remember we were supposed to take a test for the ones that didn't take that test? How does that work?
So remember that email that I sent you guys? If you guys cannot take the exam, then I'm just gonna count your final exam twice. So whatever the score that you made on your final, I'm gonna replace this grade. Like I said, right now I have a zeros on that grade for you guys, the ones who didn't take the exam.
Mm-hmm.
So it's still excuse. So I'm not gonna just put 0. I'm gonna replace with your final exam.
Okay, cool. Okay, thank you.
So don't worry about it. For right now, it says a 0, but you don't have to worry about it because whatever you make on your final, that can replace your 0. So if you do well on your final, it's gonna help you tremendously. But it will be the same thing for everybody else. Okay, our replace one of your lowest exam grade with your final grade. Say your lowest exam grade, say 20%, and you made a 70% on your final, then I put the 70 on the lowest grade and take away 20.
Oh, okay, I get you. Okay.
Right. So the ones who didn't take this exam, the last exam, your lowest grade is 0. So I definitely just replace 0 with whatever the grade that you make on your final.
Okay. And do you drop the lowest test grade or you just do that instead?
I'm not dropping, I'm replacing it with your final exam.
Okay, so you just do the replacement, not the drop. Okay.
Right. We're not dropping anything. We're just replacing. So you get to do one exam, which your final exam will do that. So try not to miss any exams. So you would take exam is always better than not taking one. But in this case, I understand because it's just school shut down on us without realizing it, right? So we understand. Okay, let's go and continue this. Is everybody there now? Is everybody good? Okay, so I'm gonna go back, taking this antiderivative of this expression right here. All right, so everybody see that I do have a u exactly same as this, right? What about dx? I mean, what about du? Du needs 2x dx. But what do I have here? Only x. So I definitely I need what class? I need to provide 2. And then I want to do what? Do the 1/2. Did everybody see where this 2 came from and where this 1/2 came from? Or if you have a question, you can write it down for me so I can read.
So on like right there by the equal sign. So basically, since we multiplied the numerator by 2, that's what made it 2x.
Right. So since I multiply 2, I need to divide it by 2 to make it to be what? 2/2, which is the same as 1.
Okay, so that's where the 1/2 came from.
Right, exactly.
Okay.
All right.
So now you can see this right there is my what?
2x
du.
dx.
Right, and this is my u, isn't it? So I have a du over u of taking antiderivative. So remember, one over u, when you take antiderivative, you get a what? Natural log. So natural log of u, but u is the same as what? X squared plus 1. So you replace u as x squared plus 1. Now I'm taking a limit. So I just call it b as b goes to infinity, and you get this. So you're replacing b as infinity. So natural log infinity is what? Infinity. Minus some middle number is still what? Infinity. So when you take antiderivative of this, you get what? Infinity. So that's why it diverges. All right, any questions? If you have questions, tell me, unmute and then talk to me so I know what's your question.
So when it becomes b, is it really just replacing x, like b becomes x at that point?
Right, exactly, because I want to take a limit.
Okay,
right, so
but where did minus 2 ln 2?
this one
Where
right
did that
here.
come from?
You plug it in.
Okay, I see it.
Yeah, 1 plus 1 give you what? 1 plus 1 give you 2.
Okay, I see it. Okay, thank you.
Okay. All right, any other questions from this slide?
Yes, I was trying to figure out the part where you're at, like where it became ln times x squared plus 1. That part's confusing me a little bit.
Okay, that's just the formula. Remember, if we have this, that is equal to net u.
Okay.
C. Yeah, that's just, yeah.
That was it.
Okay, you can still use that the sheets that I gave you. Remember all the integrations, all the derivatives, and you will see this. When you take antiderivative and 1 over u du, you get this. All right. Is everybody good? You want me to move to the next slide?
Yes, ma'am, you can.
Is everybody good? Okay. Okay, P series and the harmonic series. So I think we talked about this a little bit yesterday. Remember, I told you yesterday, I said, when you get what was the test that we did last time? Just because you get when you take a limit and you get a non-zero, then you know that it diverges. But if you get a 0, that does not mean the series is converges, okay? Remember that in that case, we have to do more tests. That's what we learned today about integral test. So now we're doing a P series and harmonic series. The second type of series has a simple arithmetic test for convergence or divergence. Okay, so whenever you have this kind of expression, we call it P series. You see that there's a P, there's a power. like 2, 3, 1, like these number is P. Whenever you have this, we call it P series. All right, where P is a positive constant, and if P equal to 1, we have a special name which called harmonic series. We start with the, when it's 1 over n, 1 over 1 is equal to 1, 1 over 2 equal to 1/2, 1 over 3 is, you know. You get this. We call it harmonic series. We have a special name for it. Now, pure series and harmonic series. General harmonic series is of this. It looks like that. All right. You use this in the music and strings of the same materials and diameters and tension and whose length from a harmonic series produce harmonic tones. That's why it's called harmonic series. So convergence of P series. They give you another theorem. Theorem says convergence of a P series. The P series converges when P is, the power is greater than 1. And then diverges when the power is in between 0 to 1. So like you have a series, 1 over n, which is going to be what? Diverges. But if you have a series 1 over n to the third, that case, what happened? Okay, it's diverges. That's what I meant to say. This is what converges, because it's n is bigger than 1. I mean, this P is bigger than 1. Yes.
Could you leave that right there on the screen and kind of explain that one more time? Because I'm trying to write it down and comprehend it at the same time.
Okay. So the P series matters about what kind of power you have.
Mm-hmm.
Okay. So if your power right here, this power.
Yes.
If this power is bigger than 1,
mm-hmm.
Okay, then it converges.
Okay.
If it's less than, between which number? I mean, it's between 0 and 1, which is this case, then it happened what? Diverge. Right. So that's why yesterday, remember we had a problem. One of the problem I told you, it doesn't converges. Remember this one that we had this problem yesterday, right?
Mm-hmm.
This one, when you do limit test, you get a what? 0. But this series diverges. You see why? The power is what? Is 1. Right, because it's a 1 is included. Anything between the P is between 0 to 1, it diverges.
Okay.
Does it make sense to you?
Mm-hmm.
Right.
Dr. Harris.
Yes.
That equation at the top, what is it like used for? The 1 over an plus b?
Oh, we'll have an example next page. Yeah, let's look at the example. So your homework has it. Okay, so we're gonna look at that. So next, I see what you're talking about. Okay. This just telling you that's a general form. Right here, that's just telling you it's a general form. Sometimes you will have a constant next to a denominator. Like this example that we have. Like this example we have is like this. And then just like you have a 0 in a way. Right, but sometimes you will have different number. It could be 3, just some different numbers you can have. That's what that means. This is just general form. But a lot of time we only see this. All right, but we can look at your homework problem because your homework problem does have a problems like that. And this will be a little more useful. This thing, you will look at it. Like I think it's lesson 3 and 4, they show this. And then you're gonna use this to compare what this is gonna be converged or not, or diverges. So I will give you a little more example, If I don't give it to you today, I will give it to you tomorrow. Okay.
Dr. Harris, could you go over the last part to where you was like it converges? I know it was something the numerator, like you did an example of like 1 over n to the third.
Yeah.
And you explained how it I didn't understand how it converges. I understand the part about how it diverges.
This one, why is it converges?
Yes, ma'am.
Because you said converges when p is what? Greater than 1. This
Okay.
case, my p is 3, which is greater than 1. That's why it will converges.
Okay. Thank you.
Sure. Is everybody okay to move to next page, next slide? We can look at the example. This is just, this is actually what we just talked about, right? You see that? So we're saying this case, it will be what? P is equal to 1. So we know right away, we will do what? Diverges. In this case, P is equal to 2. That's why it will do what? Converges. I think that's it. That's today's lesson. So if you want to, we can look at homework problem. Like a 9.3. See? Look at this one. Look at this one. 7 to the n, right? 7 to the n. So this case, we're gonna do integral test. Excuse me. Integral test. They told you to do integral test. First thing first, I'm just gonna do one example with you, okay? So if I want to do integral test, what's the criteria that we have to meet? There's 3 criteria, right? What was the first criteria? It has to be what? Positive. What's the second criteria you have to have? Continuous. What's the third one? Function is what? Decreasing. That's what we have to have. So let's looking at this. Remember, n starts with 1. So let's try it. 1 over 7(1). Is it positive? Yes. Is this function always continuous? Yes, because I cannot make 1 over 7 equal to 0. Can you do that? No, 1 over 7 is positive number. So yes, it is continuous. Yes, it's positive. Let's take a this one. If you take a derivative of that, what is that equal to? So in other words, if I can think of, what's the derivative of that? You're gonna do what? Derivative would be negative. So this is the exponential functions. I will have 7 negative x and times what? Natural log of 7 times negative 1. So it is decreasing function because of negative in here. So yes, it is a decreasing function. So this function right here meets the criteria of an integral test. Now, since it meets all 3 criteria, now I can take antiderivative. Does everybody understand about what I did right here? If you don't understand, you need to ask me so I can help you out.
So basically, you found a derivative of it?
Right, exactly. So if you want, if you don't remember this, what you have to do, just look at your sheets that I gave you. When you look at the exponential function, you will see that that's how you take a derivative. This negative 1 came from where? This negative. So this entire function is negative, so which means it's decreasing function. So now, since we checked the criteria and the criteria met, so that means I can do integral. I can take integrals. So we take integral of this. Right? When you take integral of this, and you will see that, you just look at your formula. Then it will give you it's equal to 1 over natural log of 7 times. Anyway, by the way, this is the same as right? So you have natural log negative x, and you're gonna have a negative in the front. And I'm gonna do x, I guess I can call it b if you want to. So it starts at 1 and goes to infinity, and you take a limit of that.
Where did the 2 come from?
Which 2?
In front of the integral? It's like,
I think that's an equal sign. She's talking about right behind the first dx.
This one? Right here?
Next one.
the first one.
This one? This is 1.
No, it's an equal sign. I'm sorry.
Is it equal sign? Okay.
Yes, ma'am.
Sorry.
It's
My
okay.
handwriting is very messy, as you know. So if I rewrite this problem, then I have this goes to this is a negative since I'm going to put in the bottom. All right, then I'm going to plug it in. Very first one is 1, which is fine, okay? Then I will have negative 1, natural log of 7 to infinity, you can think of, minus seven to 1.
In the denominator, is that ln of 7? Then you got like raised to b.
Right. Remember,
Okay.
I wanted something to goes to infinity.
Oh, okay, yeah, okay, I see. Yeah, because
Yeah.
the b infinity.
Yeah,
Gotcha.
because this is kind of like your b. Okay. Okay. So then when you have this, and this become a positive, but look at this thing over here. What happened here? This pretty much goes to what? 0, isn't it? Because it's a huge number. Negative 1 divided by huge number give you what? Pretty much 0. So I'm only left with this. That is equal to negative makes a positive. So positive 1 over this. Natural log of 7 over 7. That's what you have right here. Okay, does it make sense to you? Or you want me to go over again? Does anybody have a question?
I think I get it because I see how you said with the first part, you was like a smaller number divided by a larger number. It basically
Right.
makes it 0. And then so we're just
Exactly 0, right, right. So you're left with the second expression only.
Okay.
Okay, so I'm not gonna do another integral test. Let's look at the, okay, see this one right here. We're gonna do integral test. So looking at this, okay, this is again positive because it starts at 1. So this number never can be negative. And also x plus 1 can get 0, but x has to be negative 1. But our limit, our integral or limit does not start until what? Our x starts at 1. So we don't have this number in our domain. So it's still continuous. So we got three conditions. Being positive is met, continuous is met. Third, Is this decreasing? We can figure this one out. Looking at this right here, I'm just gonna look at their work so I don't have to do it. So when you take a derivative, you get this. All right, so which is less than 0, starting at x is greater than or equal to 2. So all the condition met, in other words. Okay, then we can just take integral of this. Does everybody see this one? Okay, we need to do U-test here. We need to take, okay, so we already know condition is met. So now let's take antiderivative. So we have x starts at 1, goes all the way to infinity. So I'm going to do u substitution. So which means my u is natural log x plus 1. My du is 1 over x plus 1 dx. So this problem is the same as u du. Does everybody see that? That's my u. This together is my what? Du. Does everybody see it? So that's simply this problem. Then, you know, just to simply power rules, we get u squared over 2. And I'm going to plug it in. My u is this. So I have a natural log x plus 1. I'm going to square that. And everything divided by 2. Let's just, I'm not going to just use a limit. Let's just plug it in. X equal to 1 and x goes to infinity. Then you can clearly see if you just plug it in. What happened? This whole thing is humongous, okay? Something to the square, infinity to the squared, okay? This, which means just the infinity, right? Infinity minus some little number still give you what? Infinity. So that is why this one is what? Diverges. Is everybody with me? Does anybody have questions about this problem? I just did.
I see it now. Basically,
Okay.
equals because you cannot just subtract from infinity and still not have infinity.
Right. Infinity minus small number is still what? Infinity. So when you take antiderivative of this expression, you get this, infinity. So that's why you know it's a divergence. Okay, let's see. So I'm not going to do any more integral test, but okay, what about here? Okay, what about this one? So I'm going to do one more problem and I'll let you guys go. It's been 15 minutes, but if you want to do a little longer, that is fine. But we've been doing it for 50 minutes because I set my alarm. So looking at this class, what number is this one? Right here. This is the integral test. I'm not going to do it. Oh, okay, this case, look at this one, class. Use your integral test to determine the convergence, divergence of a P-series. So this, I mean, this one, okay, this is the thing. Like when you take your exam class, I'm going to give you a choice and see how you're going to find whether the series is converges or diverges. Like this one, you know right away, it will diverges because that 0.9, the P is less than 1. Remember the P series? The particularly P series, you know right away, if the P is less than 1, that goes to what? Diverges. So you know this is diverges. Like this one over here. Over here, you can also tell again, it's a P series. What is that? This is the same as 1 over 32 over 1 over 6. Next one is 1 over 243 to 1 over 6. Next one is 1 over 1024, 1 over 6. All right. So, in other words, I can rewrite 32 as 2's. So 32 is the same as 2 to the 5th. All right, so I can rewrite this problem as, my summation. N over 5 over 6. The reason is 5 over 6 is I get a 5 here, and my denominator is what? 6. So it's 5 over 6. And my n changes. This is a 32, 2 to the 5th. This is 3 to the 5th. This is a 4 to the 5th. The next one would be 5 to the 5th. Just looking at this pattern, looking at this number, then I found the pattern to be this. So since my P is 5 over 6, which is less than 1, so the series is what? Diverges. Is everybody with me? Are you following me?
Yes, ma'am.
Okay. I think that's it. That's it. I'm not gonna do any more. I think you guys will be good. So go ahead and do your homework problem. And if you have any questions, you may ask me tomorrow. When we start our class, we can go over your homework problem first, and then we can do lesson 9.4. All right. Thank you so much, you guys. I hope you guys had a productive class. Did you guys understand okay? All right.
Yes, ma'am.
Yes, ma'am.
Okay.
I understood it better than yesterday.
Yeah, class is dismissed, and tomorrow when we're gonna meet again at 11. When you do meet, just ask me like what number you want me to do. You can chat it and put it in right here in the chat. Put it in your chat and what number you want me to do. Then I can start doing that problem before we start 9.4. All right, you guys. I will see you tomorrow. Okay.
All right.
All right. Okay. Bye.